Hi everyone. In this presentation, I will go over some exercises that you can practice with on your own. This is a good way for you to self-assess your comfort level with probability. If you're able to finish all the exercises without any problems, then you're good to go for the fall semester. You don't have to watch the lectures. However, if you struggle with the exercises, you should go back and watch the lectures and do the practices and make sure you're comfortable with all the materials before you give these exercises a try again. The goal is to be able to finish all these exercises before the end of summer so you're ready for the course. Before I present the exercises, I want to remind you this little trick which comes in handy for a lot of these problems. So in many situations, you'll find yourself needing to calculate the probability of X or Y, or the union of the two. And keep in mind that union is the probability of X plus probability of Y, and then you have to minus the intersection. Intersection is over here. Now you may be given probability of X, probability of Y, but you're not given the intersection of the two. So that may become a problem if you need to calculate the union, but you don't have information on the intersection. It may actually be easier to calculate the probability of not X intersecting with the probability of Y, and then just use this to estimate the union of X and Y by taking the complement. Okay, the key here is that these are non-independent events, so X and Y are not independent, but the not X and not Y are independent. So what you can do is you can just multiply the two together to get the intersection. However, over here, you cannot just multiply the two. So that's the main thing. Okay, so these are given usually in your problem, but this is unknown, and you can't just estimate by multiplying, so you can go the other way around. We can see that from the joint probability table. So let's say that you have X and then not X, Y and not Y. The probability of X and probability of Y are usually given. So you have these two pieces of information. However, what you don't have is the intersection between the two. So this piece is question mark. And if you need to find the union of the two, this is what you need. You need to know A plus B plus C. So you need the sum of these three regions. So you have the information on A plus C, which is probability of Y. You have the information on A plus B, which is the probability of X. But because you don't actually know the A, you are unable to estimate the union over here. So to calculate this portion is very hard, right? So this portion is this. And you need to be able to say, I want B plus C plus A. So you need P of X plus P of Y, and then you need to subtract this portion. And because you don't know the size of A, it's very difficult to figure this out. So instead of doing that, what you can do is just to calculate D. So C over D over here is available. So the area that you want is actually just 1 minus D, right? So because A, B, C, and D together is the total. So if you have the total, which is 100%, if you do 100% minus D, you'll be able to get A plus B plus C. So the region you want can be derived from 1 minus D. So what is D? So you have your given P of X, given P of Y, but you don't have A. And so what you can do is you can calculate 1 minus D instead. And what is D? Well, D is the, if If you look at not y and not x, D is the union of not x and not y. Okay, and if your not x and not y are independent of each other, you can just multiply the two together to get the union. All right, so are you ready? This is the first exercise. It has two parts. Amazon delivery operations have the daily chance of failure on each link shown below. From New York City to Philly has a failure rate of 6%. From Philly to DC, there's a failure rate of 10%. And from DC to Williamsburg, there's a failure rate of 4%. So the question for you is, what's the probability of delivery failure from New York City to Williamsburg on any given day? Assume that the links are independent of each other. So what we want is the failure rate from New York City to Williamsburg. And keep in mind that you don't need all three of them to fail. You just need one of them to fail. Because if any given one of them fails, then you will not be able to deliver. Now, if two of them fail, you won't be able to deliver. If all three of them fail, you also will not be able to deliver. So think about this. Okay, what's the easiest way to approach this problem? The second part of the exercise is based on exercise 1A. Okay, and Amazon wants to cut the chance of failure by half on any of the links by implementing blockchain technology on the link. Okay, so the probability will go from 0.06 to 0.03. For example, if you put blockchain technology on that link, how much would the failure rate improve if the whole line, so all three links, are enhanced with blockchain? The second exercise. The digital marketing team estimates that a targeted Instagram ad has a 35% chance of being clicked on. The department has a small budget, just enough to show each targeted ad 6 times. What is the probability that an ad is clicked on at least once? Okay, it's shown 6 times, so it could be clicked on 0 times, 1 time, 2 times, all the way to 6 times, right? So what's the probability that it's clicked at least once? The third exercise also has 2 parts. You work for a consulting firm that has submitted a bid to a new customer for a major project. Historically, your firm wins 40% of these bids and loses 60% of the time. The client has asked for additional information. Based on the experience, when clients ask for additional information, which we call AI, has nothing to do with artificial intelligence, the firm will win the bid 70% of the time and lose 30% of the time. Now, the first step is to fill out the joint probability table below. And then based on the joint probability table, exercise 3B asks you to consider what is the revised probability of winning the bid given that the client has just asked for additional information. Now, here's the fourth or last exercise. Again, it has 2 parts. Your organization has 7 zip cars for employees to use. So zip cars are these cars that can be shared. So you don't own the car, you just check it out whenever you need it, and then you return it when you're done. So it's like a rental car, but for like short trips, and you can do it like on a day. You don't have to go to a rental company. You can just have them on your property. 3 are hybrid, 4 are traditional gas models. You always prefer a hybrid car. Okay, so you need to use this one day. You need to use a Zipcar for a business trip, and the Zipcar system shows that only 2 are available. Calculate the probability that both of them are hybrid. Okay. So exercise 4B is the same scenario. And now for 3 consecutive days, only 2 cars available and both are hybrid. What's the probability of this happening if all cars are equally likely to be checked out and returned? And that's it. See how you feel about these exercises. You should work on these exercises before you look at the solution. The solution is in the notes section of the PowerPoint slides. So you should go look at them only after you have finished all the exercises on your own. Check the answers. If you are correct on all of them, congratulations. You're ready for the fall semester. If you struggle with any of these, it's a good idea to go back and review the materials and try again, or contact me for discussions or help. I'm always happy to help. Send me an email at rachel.chang@mason.wm.edu. Good luck. I look forward to seeing you on campus in the fall semester.